Okay, so we're going to look at Max. So Max walked up the road and then back down again, completing a 6-mile trip. So let's write it. So Max. Okay, he walked up the road, then back down again. So here distance is equal to 6. Molly, what information do we know about Molly? It's an old dog, so his max is walks at half Max's speed. So his speed is equal to s divided by 2. So therefore, let's say Max's speed is equal to s. We don't know it. Okay, and so Max reached the end of the road, and then he turned around and walked back to the starting point at his original speed. So the speeds are like sort of the same. And when he came back, he met up with Molly, who then turned around and followed Max home, still maintaining her original speed. So the speeds are the same. What we do know is that the time travelled for both of these people, both of these dogs, is the same. Okay, so they basically started and they finished at the starting point at the same time. So we're going to say time is equal to t. And here, let's say for Molly, time is equal to t. Our goal is to find the distance for Molly. So what do we know about distance? Distance, okay, is equal to speed times time. Speed times time. You can use the little triangles we did before. So here we've got speed, distance, time. Use the cover-up method. Distance is equal to speed times time. So here I'm focusing on Molly. Speed, I'm saying it's s over 2 times t. Okay. What other information do I have? So maybe I can create an equation relating speed and time regards to Max. So what do we know? Okay, time. What's time? Time, here I've used the cover-up rule, is equal to distance divided by speed. Here, distance is 6, and the speed is s. Okay, so I'm just going to plug that information in. So s over 2 multiplied by 6 divided by s. Okay, here we should see that the s's cancel. So we have 6 divided by 2, and then here this is equal to 3. So it's 3 miles. Okay, so what do we know about Supergram? So when she's traveling and speed of 6 miles per hour, the speed is equal to 6, she'll arrive at 1 p.m. So here, let's call the time is equal to t, okay, and the distance, let's call it t. Okay, so let's make a relationship between this. So we have speed, which is 6, is equal to distance divided by time. Then what else do we know? So if she leaves at the same time and walks at 10 miles per hour, so speed, this is with speed is equal to 10 miles per hour, she'll arrive at 11 a.m. So this is going to be time is equal to t, and this is going to be subtracting 2 hours. And the distance is going to be the same, so distance is equal to d. Let's create an equation here. So we have speed, which is 10, is is equal to distance divided by time, which is t minus 2. So we want to try to solve this. How can we do this? We can rearrange this. This is d is equal to 6 times t. Okay, and here this d can be written as d is equal to 10 multiplied by t minus 2. Okay, so we have d is equal to 6t and d is equal to 10 times t minus 2. So the d's are equal, so 6t is equal to 10 times t minus 2. So here we can expand this. So this is going to be 10t minus 20. Okay, and we want to solve this. So 6t is equal to 10t minus 20. So let's subtract 6t from both sides and add 20. So add 20 to both sides. We're going to have got 20 is equal to 40. So t is equal to 5. Okay, so we're going to use that information to work out the speed that you must travel so that you arrive at 12 noon. Okay, so let's make a bit of space here. So this is what we are trying to solve. What do we know? We're trying to work out the speed. So speed, okay, and this is equal to distance, and this is going to be divided by time. And the time here is 12 noon. So if it's with t for 1 p.m., the time is t. 12 noon, this is going to be t minus 1. Okay, so we know what t is. T is equal to 5. So here we've got 5 minus 1, so that's going to be 4. Do we know what d is? The distance here is equal to 6t. So you can use either equation. You can use 6t or t times, so 10 times t minus 2. It's up to you, what you prefer. I'm using this first one because it's more simpler. So this is 6 times t. T is 5. So here this is equal to 30. Okay. So now we've got what d is. It's 30. So 30 divided by 4 is 7.5. So here it's going to be 7.5 miles per an hour. So speed is equal to 7.5 miles per hour. Okay, so let's go through it. Let's break it up into two parts. The first part is travelling by car. So speed is equal to 55, and we have time, which is equal to 2 hours, and the distance is equal to speed times time. So 55 multiplied by 2 is 110 miles. Okay, second part, this is going by plane. Okay, speed, what do we know about speed? Speed is equal to 70. Time, I'm going to define t as the entire time for the journey. So time traveling to Birmingham by car and then by a plane. So t is the entire time. So here, time is equal to, since 2 of those hours was used for driving, this is going to be written as the entire time minus 2. and then distance. Okay, we use another letter d, which is entire distance. Okay, so this is a combination of travelling by car and then by plane. So here we have d, and then subtract the 110. Okay, so let's put it all together. So the entire journey. Okay, so we are looking for the time for the entire journey. Okay, and we defined it as t. So time. So let's remind ourselves what time is. So we've got speed is distance divided by time. So time is distance divided by speed. Distance divided by speed. Okay, distance we defined as d. Speed here it says the speed is 60 miles per hour. Okay, now we need to relate d with t. There are too many unknowns. So looking at this first one here, we can see that here we have speed is 70, distance divided by time is d minus 110 over t minus 2, multiply both sides by t minus 2, this is going to be 70 times t minus 2 is equal to d minus 110. Then we need to expand this. This is going to be 70t minus 140 is equal to d minus 110. And then we add 110 to both sides. So 70t minus 30 is equal to d. So here we know that d is 70t minus 30 divided by 60. Okay, we're trying to find our t, which is the entire time. So let's multiply both sides by 60. So we've got 60t is equal to 70t minus 30. We can subtract 70t from both sides. So this is going to be negative 10t is equal to negative 30. And our t value is equal to, so divide by negative 10, both sides, so t is equal to 3 hours. Okay, so t is equal to 3 hours. Okay, so let's have a look at this question. We have Harriet the hare and Turtle Tortoise want to cross the finish line together on their 12-mile woodland race. So Turbo. So let's have a look at Turbo. So Turbo. Firstly, we know the distance is 12. Okay, and Turbo sets off at 8:15 a.m. and trots at a constant speed of 4 miles per hour. So the speed is equal to 4 miles per hour. Okay, so great. So let's say look at the time of Turbo the tortoise. Let's call it t. And let's have a look at Harriet. Okay, Harriet here. Again, the distance is going to be 12. Okay, and the speed is going to be a bit faster. It's going to be 8 miles per hour. Okay, and okay, so what we're trying to get. So the aim is for them to travel at the finishing line together. So, so there's going to be a difference in time, isn't it? So there's going to be a bit of a lag here. So here it's going to be time, which is time of turbo, but there's going to be a bit of a lag. I'm going to call it L, meaning the lag. Okay, so this is time is equal to this is turbo's time, which is T minus the lag. Okay, let's get some information here. What do we know about T? Here it's time. Let's use the triangle. So we have speed, distance, and then time. Time is distance divided by speed. So here this is equal to 12 divided by 4. So the time is 3. So here the time for Harriet is going to be 3 minus L. Let's again relate things. I'm going to say find the time in terms of distance and speed. So time here is 3 minus L. Distance is 12 over the speed. Okay. And here's 12 divided by 8 is 1.5. Okay, so when I solve this equation, so we've got 3 minus L is equal to 1.5. So here this is 3 minus 1.5 is equal to L. So L is equal to 1.5. Okay, so the lag is 1.5 hours. Okay. So Harriet her hair, okay, needs to have a delay of 1.5 hours. Okay, so if turbo sets off at 8:15, an hour and a half later will be 9:45. So the solution is A. That's an hour and a half later. Okay, so platinum is a rare metal, even rarer than gold. Its density is 21.45 grams per centimeter cubed. Assuming the bulk production has been about 110 tons for each of the past 50 years, and negligible before that, which of the following has a comparable volume to that of the total amount of platinum ever produced? Okay, so we'll have really need to remember the formula. So mass is equal to volume times density times density. Okay, you can use the triangle if you prefer. So we've got this is your mass, this is your volume times density. So volume is equal to mass times density. Mass divided by density. Okay, so for platinum, the mass is 110 tons, and then the density is 21.45. Okay, so we've got to be careful here. So we've got to convert the tons into grams. So tons, 1 ton is 1,000,000 grams. Okay, so this is going to be approximately equal to, so assuming you don't have any calculator, this is going to be approximately equal to, say, 5 million. Okay, 5 million centimeter cubed. Okay, which is roughly the same size as Buckingham Palace.